Good morning everyone. Today we are going to learn about encryption techniques, and our contents are Symmetric Cipher model, where we are going to learn about the cryptography, crypt analysis, brute force attack, as well as we are going to learn about many techniques, substitution techniques like Caesar cipher, mono alphabetic cipher, Mayfair, Playfair cipher, Hill cipher, and many others. And also we are going to learn about the transposition techniques, and along with this we are also going with the rotor machine and steganography. So let's start with the first, that is symmetric cipher. In symmetric cipher, normally we are going to convert our message from plain text to ciphertext, where we are going to use just one key. So normally it is called as conventional encryption or a single key encryption method, and it was developed during 1970s. Symmetric encryption, you can see the picture and you can find out like we are using just one key for encrypting at the sender side as well as at the receiver side. Say for example, Bob wants to send a message to Alice, and Bob is using some encryption technique, and using this technique he is transmitting the message hello Alice. And here, like when you are going to encrypt the message using the same key or symmetric key, we will get some cipher which is not readable, which is not in readable form, which is intangible. And if in between Bob and Alice, if someone is going to get the text, he or she could not identify what the message is. So at the receiver end, when Alice is going to get the message, she is supposed to know the key which is shared by both Bob and Alice. So now what Alice is going to do, Alice will find out the key, she will apply the key on the message received from the Bob, and Alice will try to decrypt the message and she will get the message hello Alice. So that's the whole idea behind the symmetric key or symmetric cipher model. So as I said, like we are going to deal with just one key, that is symmetric key shared by both sender and receiver, and some of the key terms that we are going to use during this entire process is plain text, encryption algorithm, secret key, ciphertext, decryption algorithm. So let's start with the first one, that is plain text. Normally that is the original message sent by the sender and which is in a readable form. Like using some technique, some algorithm, some methods, what sender will do? Sender can encrypt the message into a form which is intangible, which is not readable by anyone. So the technique is called encryption, or you can say that algorithm it as encryption algorithm. Now another term, secret key, comes into the picture. That is the most important thing for any person who is trying to encrypt the message. This secret key is the key that will help you to encrypt your message, and like the same key has been used for decrypting the message at the receiver side. So the key which is going to be shared by both sender and receiver need to be confidential between these two parties who are going to doing this kind of conversation. Like at the end where message is going to be delivered, receiver will use this key and will decrypt the key and decrypt the message and will get the text. So that is the whole idea behind this symmetric cipher model. You can see the picture, like picture is going to give complete idea about how we can apply the key, how we can use the algorithm, and how we can send the message and receiver can receive the message without any loss or without like knowing to others, or we can make our whole process secret. There are like two basic requirements for applying this symmetric cipher model. The first is you are supposed to have a strong algorithm. Like if I am going to develop one algorithm and tomorrow if someone is going to come and going to know the steps and easily can crack your algorithm, that should not happen. It means that your algorithm must be strong enough. Second thing is the key, secret key, which is going to be shared by sender and receiver, not with the some other third party. So it means that only sender and receiver must know the key, no one else. So that's the key points. You can, like here we can see like all that picture we have seen over here, we can put it in a documentation form. Like you can see K is the key, and you can see message X is going to be encrypted, and X1, X2 till Xn can be the part of your message, means the different letters that you are going to pass in your message, we are going to put over here. We are going to use key K, where the K1, K2, Kn are the key elements that you are going to use to encrypt your message. You can like put in a form of equation like y is equal to encryption function that will use two things, that is the key and the original message. At the receiver side, where you are going to decrypt your message, we can see the message is X that can be decrypted using the decryption algorithm with the help of key and your ciphertext, that is that we have encrypted earlier. So the equation will be X is equal to d k of y. So you can see in this picture, like sender is going to send a message in a form of, like you can say message source, message is X, and we are going to apply some algorithm, encryption algorithm over here, which will take the help of key, that is key source. You are going to apply the key, and like once you apply the key, you will have a ciphertext, that is y is equal to E, like E is the encryption algorithm where you are going to apply key K and plain text is X. And at the receiver side, like the whole message is going to be transmitted over this channel and will be received at the other end, and at the receiver end, receiver is going to decrypt the message using the same like decryption function, that is X is equal to D using the key K and the ciphertext Y. So receiver side, receiver is going to receive the message and he or she can read the message. But in between, if in between your receiver and sender, if someone else is going to come, like let's say it's a hacker. So what is going to happen? Hacker will try to, find out what is the key, what is the ciphertext. So he or she can apply different keys or might be trying to get original message, and he will manipulate some of the keys and will try to receive the message. But we are supposed to have a algorithm in such a way that no one can find it out. So then and then only we can say our whole transmission or whole conversation is going to be a secret one. Now here we can see like what are the key points that we are supposed to remember while we are going to apply asymmetric cipher model. The first thing is like the type of operations for the transforming the plain text to the ciphertext. Like whatever steps we are going to follow for converting our text from cipher to from plain text to cipher, we are supposed to make it very strong. Like it should be that no one can come and easily can find out what you are doing. Next is number of keys. Like when you are talking about keys, normally there are two keys. If you are going to use one key, that is symmetric key for both encryption and decryption, it is a symmetric cipher model. And if you are using two different keys at the both hand, like sender is going to encrypt the message using one key and receiver can use different key for decrypting the message, that is called public key encryption. So it also depends on the number of keys that someone is using. And finally, the way in which plain text is processed. So we are also going to focus the process that we are going to follow for transmitting the message from one end to another end. So these three are key points while we are going to apply this algorithm. Now we will talk about crypt analysis. Crypt analysis is a kind of observation that someone is doing while message is transmitting from one end to another end. Let's say like party A and B are talking. A wants to talk to B and while they talk to each other, in between A and B, some C will come into the picture and C will try to listen. So what is going to happen, like when I am sending a message from A to B, C is going to listen the same thing, and might be this C can manipulate the message and can retransmit to B. So now I can call this person as a hacker, or you can also say that is the crypt analysis. Next is brute force attack. In brute force attack, normally what people are doing, like people like crypt analysts or maybe hackers, they simply try, like they are getting ciphertext. When A is sending a message to B, A always take care like message is encrypted properly. So encrypted message is now going to travel through the channel, like this is your channel, and at the other end B is going to receive the encrypted message. Now like if C is going to test this message, what C is having, it is encrypted message which is not in a readable form. So now what C will try to do, C can apply different keys and will try to get the message in a plain text. So this technique is called as brute force attack, like applying different keys and trying to get the expected outcomes from the ciphertext. That whole process is called as brute force attack. Well, like as we know, like all these are basic things, but now let's see like how exactly we can encrypt the message. Like there are different techniques, like you can see Caesar cipher, which is the most simplest technique for encrypting any message. So let's talk about Caesar cipher. It was developed by Julius Caesar years ago, and normally like main focus was on alphabets. Like as all of you know that there are 26 alphabets in our 26 letters in our alphabets. So what is the idea, like we can just put them on a piece of paper, and what we can do, like we can just think like how many steps I want to shift my particular word. Like let's say I want to transmit a message that is hello. Now I will just find out like where H stands in my this hierarchy. So for H I am going to substitute other letter, and what I'll try to do, I'll just try to shift my whole alphabets with any number, like it can be 2, 3 or any number. If let's say if the shifting number is 3, then 3 will become my key. So 3 is my key. It means that all the letters in my alphabet I am going to shift with the 3. So now my A will become D, B will become E, and like that we can go. So now just find out what stands for H. So I can say for H I can have like mapping letter K. Next is E. So I'll find out mapping letter for E, that is H. So my next this is, you can say this is your plain text and this is your ciphertext. So E, then L will come. So for L you can see over here that is O, the equivalent alphabet for L is O. Same for L again, so again O, and finally we are having O. The last word in my message is hello, that is O. So I'll just find out what is the mapping letter in my this table, that is R. So for my plain text hello, I can have a ciphertext KHOOR, which can be my ciphertext. So while I am transmitting my message, what I am going to do, I am not going to send hello as a string, but I'll send KHOOR as a string through the channel. And at the receiver side, when receiver is going to receive this message, he or she is supposed to do it in a reverse form, so that she can have hello as a string. So what she can do, he or she can do, simply can see, I am also supposed to share my key, that is 3. It means that he or she will come to know like 3 is my key. It means that I have shifted all my letters 3 in a upper bound. So now what I am going to do, I am just going to shift it back three back in my alphabet. So I will find out according later for k. So if I will use this table again, so I just need to go from bottom to top. That is, first is k. So the mapping letter for the k is h. H. Then for h I can find out the mapping letter is e. So I am going to put e. Again I am having double O, so I will just find out where is O, it is here. So for O the equivalent letter is L. So I will put L, and then finally I will search for R, and for R the mapping letter is O. So now that's the whole string. You can, like, receiver can see, like, the message is hello. That's the whole process or whole technique in Caesar cipher.